so we're working on figuring out how to graph the line a second way this time, okay? So we know we're working on the section, you know how 4-1 was find the slope, find the slope, find the slope? 3 different ways. 4-2 is graph it, graph it, graph it. 3 different ways. So yesterday we learned that you can make a table of values every single time. So if you make a table of values and then plot the points, you can't go wrong. So making a table of values works every single time. It's a little tedious though. And by tedious I mean kind of takes a long time. You have to do a lot of little math. And when you do lots of little math, sometimes we make mistakes. So it's not the best way. Okay? So the way we're going to talk about today, which is part 2, is use slope-intercept form. And slope-intercept form is kind of like, almost like a shortcut. It's a really, really, really fast way to do it. But remember, if you forget it for the time being, you always can fall back on the table. And then tomorrow, we're going to actually find the x and y intercepts. Okay? So there's 3 ways to graph a linear equation. We are on number 2 right now. Okay. So for slope-intercept form, the first thing I want to do is just kind of show you something. And on your paper, we're going to play around with our calculator in a minute. Just don't turn it on yet. I want you to write something called y equals x. All right? And right next to this, I want you to write, and I'm going to do it in red, just you'll see why for later, what this is. Y equals x is considered the parent function. Kind of like we have standards that are called parent standards, right? And when we learn parent standards, underneath parent standards, there's like different ways to alter that, right? So a parent function looks like this. Let's make a table of values. That means whatever you choose for x, that y is the same. Yeah. So whatever you make x, y is equal to it. So if x is -1, so is y. If x is 0, so is y. And if x is 1, so is y. So let's kind of just do a quick little sketch. A sketch means I don't have awesome graph paper with all the grid lines. Let's just sketch it. So this means -1, -1. Go down 1, left 1. 0, 0 means don't go anywhere. And 1, 1 means go to the right 1, go up 1. And so when I connect this, number 1, it should be a straight line, because that's the definition of linear function. And that is what units 4 and 5 are all about. So everything we're doing needs to be a straight line for this whole trimester. If you get one little point out of line, you did some math wrong, right? So that is the parent function. So let's throw a little geometry in here. In a parent actually in any grid, all the coordinates form what? What kind of angle is quadrant 1 formed? It's a 90-degree angle. That's a right angle, right? Okay? There's 2 ways to say it. So what the parent function does is splits quadrant 1 exactly right down the middle. And what's half of a 90-degree angle? I almost said it. 45 degrees, right? So if we're talking angles, that this is exactly half of that. And here's the other thing to think about. If we're going by slope, you know what that is? To get to that, I went up 1 and over 1. It's your regular little staircase. If I kept going up 1 unit and over another unit and up 1 unit and over, I would keep landing on the line. Another way to do that instead of going up and right would be to go down 1 and left 1, down 1 and left 1, down and left, and I would keep falling on the line. That's called your parent function. Everything is born from the parent function, which is why they call it parents, right? So we're going to see how we can change and build on the parent function. So let's talk about this calculator in front of you right now. So up until now, really, what we use the calculator for is calculations. I actually logged onto a calculator the other day, and I saw this problem, and I almost, sat and cried. Okay, somebody used the calculator to do 2 minus 3. I do teach a math skills class. Maybe that was the class that it was for. I'm hoping, but you know that 2 plus negative 3 is negative 1. We don't want to rely too heavily on this little device to do the little simple calculations, right? Because it's really meant for bigger and better things. So this is called a TI-84, okay? This is the calculators that Mr. Meeks had last year, right? We use these a lot. All right, the things you used it for, you probably could take a little blue solar calculator and still get done what you need because you guys are using it to check math. We're going way beyond that. We're going to actually graph some linear functions on this. Some of these are even like computers, like the TI, those are called Inspires. Those actually have a little Wi-Fi. I can send things. You can save documents and folders, but we don't need to get that crazy. So I want to show you a function, and it has to do with these top buttons up here. Okay, so this button right here, y equals, and this button here, the window. So I want you to, on your calculator, just hit the window button. And I know that your window is set because I used these second hour and I had them set it. But what a window is, you're going to see a bunch of stuff, and there's some stuff I don't want you even to pay attention to. I want you to look at the x-min and the x-max, the y-min and the y-max, and the scale just means what do you want your axes to go by. We always just want to stick to ones. So if we're talking coordinate plane, and I'm looking at a graph right here, north, south, west, or east, which one do you think is my x-min? Min stands for minimum, by the way. Minimum means how low can it go? Or in this case, how far to the left do you want it to go? So this part right here is called our x-min. It's how far do you want your x-axis to go, which would make our x-max. How far to the right do you want your x-axis to go? So we're going to call this our x-max. So now you can probably figure out which one the y-min and the y-max is, right? So this is going to be my minimum y value, which was why we call it y-min, which would make this our y-max. So I'm telling you this because sometimes when your window is a little out of whack, your whole graph may not show up. So for example, if I just wanted my graph on here to show, actually let me just show you. I'm going to show you what that is. Oh, I'm going to go in and clear something out. See how you can see all 4 quadrants? So don't do any of this yet. So there's my 4 quadrants. Negative 10, positive 10, negative 10, positive 10. But you know how we do like a Google Earth and sometimes we want to zoom in on this quadrant 1? I would go to window and I would say I want my x-min to only go to 0. And my y-min to only go to 0. And then when I graph that, I only see quadrant 1. Sometimes I kind of like to be able to see a little bit of each of those axes, so I'll maybe put a negative, oops, not 0.1, a negative 1. Yeah, that would make it really small. And so you can kind of see quadrant 2, 3, and 4 kind of hiding there, right? But if I want to do my regular window, then I just want to do negative 10 all around. So if you ever can't see your full graph, you know where to fix it, right? Okay. So now let's talk about how do we get the lines on the graphs. And now that we're using this calculator as like a discovery activity. So I'm not going to come out and say this number does this and this number does this. You're going to figure it out, which means by the end of the hour, you're going to know how to graph a linear function on the calculator, which means can you use a calculator on this next test? No, because it'll do it for you. It'll graph it for you. Okay, so ready? First thing I want you to do is hit this y equals. And if there's anything in your y equals, clear it out. You use this keypad here to just kind of scroll up and down and hit clear. So I want you to have it where there's nothing in it. Okay? You also want to make sure any of your plots are turned off. Does anybody have any of these 3 things highlighted? And by highlighted, I mean, does it look like that? If it does, when we graph, it's going to give you an error. So I want you to go up to it. By hitting enter, you're turning it off. And then scroll back down. Okay. So here we go. Let's graph our parent function. The x that we're going to use is going to be right next to the alpha. So this is our x and our t and our theta and so on. So go ahead and hit y equals in your first equation, y equals x. And then if you want this equation to graph, you need to tell it to graph. Say, okay, calculator, I just typed in an equation. It's y equals x. So you want to tell it to graph. So hit the graph button. And you should see a line kind of starting to shoot through that x and y axis at the origin. That's called your parent function, guys. Can you see on here? Can you see if I start here that I went up 1 over 1, up 1 over 1? It's like little steps. That's all it is. Okay? So are you good with that? All right. So now let's talk about, if I go back to this for a second and I take this parent function and I add something to it. Let's take this parent function, which is y equals x, and let's just say y equals x, and let's add 2 to it. So what that means is, instead of y being negative 1, 0, and 1, it's going to be whatever that is, but plus 2. So that would turn this into what? What's negative 1 plus 2? Positive 1. What's 0 plus 2? And what's y plus 2? So that would make these all of the y values, but or all the x values plus 2. So when we go to graph that, actually we can graph it on the same graph up here. This time I'm going to plot negative 1, positive 1, and 0, 2, and 1, 3. And so this time, this graph, and I went a little bit off. That's why I want to show it to you on the calculator. So let's go to this. Let's go back and open up our y equals. And let's keep the y equals x there. I don't want that to ever go away because we're comparing everything to that. If I type in y equals x plus 2 and hit graph, and mine is fancy, it's a different color, so you're going to see it in a different color. Sorry, you just have old pixelated. Do you see why that works? So that's y equals x plus 2 more. Look at it. All it does is it takes every one of these points and adds 2 to it. If this was 1, now it's 3. If this was 3, now it's 5. So what did I do by adding a number after the x? I shifted it up, right? Okay? So if I say y equals x plus 5, then this next one's going to go through 5 on the y-axis. Right? Okay. So I want you, and here's what we're going to do today. I'm going to pull my calculator away. I'm going to type something in, and you have to try to match it. Oh, you can't see it because it's a different color. There it is. I want you to try to match that line. You have to know what I typed in to get that line down that far. And if you can, show me your screen. And so I know exactly what you did to get it there. So go ahead and type in what you have to get your screen to match that. Yep. See? Yeah. A lot of times what you guys have to keep in mind, because you don't have anything there. So, well, you want to do x plus 2. Yes, you still leave that. So leave that first one in. So, what did you type in to get your line to shift down to negative 4 on the y-axis? Y equals x and then minus 4. So, here's what we're hoping to discover with this. That the number after the x that you're either adding or subtracting controls where it touches the y-axis at, right? So this is our beginning value. I'm starting on the y-axis. Where am I starting on the y-axis? Here, 0. Here, 1. Here, 5. Here, negative 4. That's your b. Have you heard me say y equals mx plus b? B is your beginning value. That's where we start, okay? So, let's do this. I want you to go in through and clear out all this stuff, okay? And we're going to discover and play around with 2 more things, okay? So, the other thing I want to do before I hit graph, and don't cheat, you know the negative button is underneath the 3, right? It's not the minus. So if I make x negative, don't hit graph, what's your guess? It means the number in front of x is your slope. And if the number in front of x, which in this case is a 1, is negative, if the slope is going to do what? Go down from left to right. So let's take a look at our parent function, which is positive. And there's our negative x. Kind of cool, huh? So I want you to see something. As I'm doing this and I'm going up 1 over 1, up 1 over 1, up 1 over 1, what's the slope of a negative x? Not up 1 and right 1, but down 1, right 1, down 1 and right 1. These are our basic staircases. Here's the steps that I'm climbing up. I'm going to my upstairs. And this one I'm going to my downstairs. These are my downstairs steps. Okay? Good? So I'm going to ask you, thank you, Brenna, I'm going to pull this away for a minute. And I'm going to ask you to try and plot this one. Try to get your graph to match this. So what do you have to manipulate in that formula? What do you need to change to get it to go negative and shift up 3? My new beginning value is where it's at on the y-axis. I need to know what that point is, and I need to know what number in my equation makes my line get to that point. All right. Raise your screens if you got your line up that way. Good. Okay. All right. So you had to get it negative, and you had to shift it up 3. So do you have negative x plus 3? Okay. All right. Let's see who was listening for special cases. Oh, I shouldn't have even given you that. That's your y equals x. Everything is compared to the parent function. What is going on there? What do I type in to get a horizontal line? Show me a horizontal line on your paper. You get a fire part. Horizontal line. What did I type in to get that? Remember that sheet that I said, hey, special cases, they're popping up everywhere. Make sure you know how to do them. Hey, what kind of line is that? I know it's straight, but it's also what? Horizontal. What kind of slope does a horizontal line have? 0. And if the number in front of your slope, or if the number in front of your x is the slope, you have 2 options of how you can do this. So option 1 is to say, I'll show you what I typed in. Y equals 2. Y equals 2 is a horizontal line. Some people may have put 0x plus 2, and that works also. I mean, it looks, did you see it just kind of change colors? So it put it right on top of it, because y equals 2 and y equals 0x plus 2 are the same thing, but guess what? You'll never, ever, ever see 0x. Because if there are no x's, then why even put an x? It's like saying, oh, by the way, there's 0 a's also. So should I put 0a and 0b and 0? No. Your coefficient does not need to be 0. So we don't really use this one. We just use this one. Okay? We can't get a vertical line on here right now because all these y's are pre-programmed in, and I would have to change the y to a what if I wanted to plot a vertical line, an x. And right now I'm not going through those functions with you. Okay? All right. So, do we know what the number after does? And let's just kind of look at this for a minute. I'm going to show you. So, what was the number after the x here? 0. So, where did you expect it to touch the y-axis? 0. Let's see if this is true. What's the number after x here? Where did you expect it to touch the y-axis? -2. -2. That's a special case. -4. -4 and +5, +5. That's called the Y-intercept. That's where you begin when you graph tomorrow when we graph, and I need you to know that point. Okay? So now we got to talk about what this 1/5 does, and what this 2 does, and what this 1/3 and 5/3 does. So, go back and clear everything out except for your parent function. So keep in your y equals x. And so now I want to put a number in front of the x. So don't do anything yet, please. So let's look over here, and we did x plus 2, right? Let's take and put a number in front of the x. Let's do a coefficient of x. So here's my parent function. Let's see what y equals 2x does to it. Don't graph it yet, okay? X, y, we got to build up some suspense, right? So what's -1 times 2? 0 times 2. 1 times 2. So when I go to plot this, here's my parent function right through the middle, up 1 over 1. Here's -1, except going down 1, I go down 2. 0, 0 has not changed, but 1, 2 changed. And so what does that do to the line? So let's go ahead and in here, graph the 1/2. And 1/2 is just 1 divided by 2. You know that, right? That's just the division bar. Don't forget your x, otherwise you'll get a straight horizontal line. So there's my parent function. Oh, guess what? I'm sorry. I didn't mean to do the 1/2 x. I was jumping the gun. So you got a little preview. We did 2x. Sorry. So y equals 2x. Takes a little bit of the suspense out for the next move, doesn't it? So let's talk about what this 2 means. Like so often in algebra, all the 13 and 14-year-olds in my class just say, oh, there's a number in front of x. I don't really know what it means. I just know that it's there. Well, here's what it means. It means if I were climbing stairs, and if I were climbing this red line, that would be my regular upstairs, downstairs, right? But have you ever been on a flight of stairs where instead of going up 1 over 1, up 1 over 1, you went up 2 and over 1? Up 2 and over 1? Like the steps are so big, like to climb them you have to like do really big steps, right? Whether it's at a museum or somewhere. So that means the rise is twice as tall. You know the back of the stair? It's twice as tall as this one, which means it's a steeper flight of stairs. So what is putting a whole number bigger than 1, because 1 is your parent function, 2x, 3x, play around a little bit. Start to play around and see what 4x would look like. See what 20x. Somebody typed in 100x. And it was so steep that it almost looked like what kind of a line? Vertical. So go around and just kind of leave your 2x there. Maybe see what 5x would do. Maybe see what 50x would do. So take a minute to just kind of see what that number does when you alter it. It almost looks so steep you can't even see it, especially on your little pixelized screens, right? Oh, I hate it. Yeah, this one. There we go. See, so this is obviously my parent function red, 2x, y equals 5x, y equals 100x. Or 50x. All right. So you ready to match mine? Try to match this. So go ahead and clear out everything except your parent function. I'm going to pull this away for a second. And I want you to try to match this one. Ooh. Parent function. So, I messed with you and I did all 3 things that we've learned to it. So, not only is it a negative slope, it's pretty steep, and I shifted it up. Hold your screen up when you think you can match it. And you know what? So cool. Some people just say, it's steeper, I'm just going to guess, and I see other people doing this. What are they doing? Can you find the slope out from the blue line? Could you pick where you're starting and go? Could you? Guess what? I hope, because that's what we just took a test on like 2 days ago, is finding the slope from a line, right? Use what you learned. Awesome, Peter. Good. Good. You have to do 3 things to it. Yep. Awesome. Hold your screen up when you have it. It's basically playing little things like this that's helping us get to know the formula. So, got it? Can you see? Good. Yep. We pass this over to Colin, please. All right, ready? So I'm going to pull this away a little bit. Hold on. I'm going to clear this one out, and I'm going to say, how did I get it to go negative? I've made it negative. How did I get it to be a little bit steeper than the parent function of 1? I made it a 2 or a 3 or a 4. You could have guessed, but did anybody actually do the over and up? And if you did that, you found out that it was 3. Don't forget. This is what people forget. They forget where the x goes. If that's the slope, then it has to be the number in front of x, so I have to put the x. And then where did it touch the y-axis at? +4. So that's what you need to have typed in. So go ahead and do that. And then we want to try another one. Graph. Okay. So before we try another one, I want to show you this. So let's take a look at this. That was that one. Y equals, instead of y equals 2x, let's do y equals 1/2 x. All right. So now that I got a fraction, that kind of affects what numbers I want to put here. I don't want to put 1 because I don't want to deal with the fraction. So what should I choose as my domain for my x? -2, 0, +2. Now let's plug this in here. And what's half of -2? What's half of 0? And what's half of 2? So watch. If this is my parent function, which is up 1 over 1, this is the opposite kind of staircase. This, instead of going up 2 over 1, up 2 over 1, I'm only going to go up 1, but over 2. Up 1, but over 2. And so this line is less steep. I can't remember. I think it's a museum somewhere where the steps are literally like really long right here. Have you ever been up or down a flight? You know, it feels weird. Like you don't feel like you're walking. Like you're like, oh my gosh, I feel like I should be lifting my legs up, but I'm not. So let's take a look at what that looks like. And that's where I had the 1/2 entered before. The number in front, don't forget your x. And then when you graph it, you're going to see that compared to the parent function, everything is compared to the parent function. I'm not going up 1 over 1, up 1 over 1. I'm going up 1, but over 2, which is why that step is so long. All right? What's kind of nice to see is all of them together. This is your y equals x. If we're comparing everything to the red parent function, which is 1 over 1, 1 over 1, this is up 2 over 1, up 2 over 1, 2 over 1. And this is up 1 over 2, up 1 over 2, up 1 over 2. Yes?
When you start the angle, it just cut like the 45-degree angle.
Yes, it just cuts that 45-degree angle in half, yeah. Okay, you ready to try to match one? Mm-hmm. All right. I'm going to try to get you. All right. How about this? Here's the parent function. Oh, I know why. I know why. Everything I just told you guys not to do. I used all right. That was suspenseful. Is it a positive or negative slope? It's not very steep at all. I need to give you a minute to play around. And you know what? You have to make mistakes. You have to type something in, you have to hit graph, and you have to see what it does. And if it matches it, awesome. If it doesn't, go back and clear it. Try something else. Some people are actually saying, well, I'm not going to guess. I'm going to find the exact darn slope and type it in. Awesome. You got to just trial and error it. Put a number in, see what it does. Did you get it? Yeah. All right, so here's my hints to you. This number right here is called the Y-intercept, and it's the number that's after. So that's 1, 2, 3, 4, 5. So what do you know is at the end? A plus 5. Is it the number in front? That's tricky. Okay, so is the slope a positive or negative? Negative. So I know it's going to start with a negative. I know it's going to have a plus 5 at the end. I just got to figure out what to put in front of the x. Well, is it steeper compared to the up 1 over 1 or less steep? So it needs to be a fraction. 1/2 wasn't really that steep. So if you look at it, I made it 1/4. I made it negative. And then it went up 5. I'll show you what negative 1/2 x would look like. Plus 5. So, was there any way to really know that it was a 1/4 instead of a 1/2? Yeah, I mean, my grid is, I don't have the grid lines on my calculator, but could you have kind of said up, down 1 over 4 or 5? Yeah.
I did that and went straight to an arrow.
Okay, do you have a minus sign instead of the negative?
Not
That might be it. Okay, so that is how you figure out, like, actually what the